The realm of mathematics, often perceived as the purest form of abstract thought, occasionally encounters enigmatic entities that challenge its foundational principles and expose the inherent limitations of its axiomatic systems. Among these intriguing paradoxes, the Vitali set stands as a stark example, a subset of the real numbers, constructed through the seemingly innocuous axiom of choice that defies Lebesgue measurability, our standard way of assigning a size or length to sets. This non-measurability has led to a sense of incompleteness within the mathematical models that attempt to encompass such entities. However, by venturing beyond the confines of purely abstract mathematics and considering the potential physical implications of the axiom of choice within the framework of the 11-dimensional model, we might uncover a resolution to this incompleteness, proposing that the choice inherent in the axiom is not arbitrary, but rather a manifestation of a fundamental geometric principle, the intrinsic centrality of physical objects within a higher dimensional reality. The axiom of choice, a foundational principle in Zermelo-Fraenkel set theory, asserts that for any collection of non-empty sets, there exists a set containing exactly one element from each set in the collection. While seemingly intuitive, this axiom has profound and sometimes counterintuitive consequences, most notably in the construction of non-measurable sets like the Vitali set. Media group number line partition interval. The Vitali construction involves partitioning the interval 0, 1 into equivalence classes based on rational differences, and then invoking the axiom of choice to select a single representative from each class. The resulting Vitali set, while mathematically constructible, cannot be assigned a Lebesgue measure without leading to contradictions, highlighting a fundamental limitation in our ability to consistently quantify all subsets of the real numbers. This non-measurability can be perceived as an incompleteness within the mathematical model, a boundary beyond which our standard tools of measurement fail. In contrast to the abstract landscape of set theory, the 11-dimensional model, as we have been exploring, posits a universe with a rich and inherently geometric structure. It envisions a reality extending beyond our familiar 4 dimensions, encompassing a hierarchy of interconnected realms where fundamental properties like rotation and polarity define the nature of entities across all scales. At the heart of this model lies the 0 dimension, a point of pure potentiality, the ultimate origin and center from which all other dimensions and physical manifestations emerge. This central role of the 0 dimension, the foundational point of existence, resonates with the significance of the center in geometric objects, a unique point of balance, symmetry, and inherent definition. The center of a geometric object, whether a simple line segment or a complex 11-dimensional manifold, possesses a fundamental invariance. It is a uniquely defined point that anchors the object's existence and dictates its spatial or multi-dimensional relationships. In a higher dimensional space, where geometry becomes increasingly intricate and the interplay of dimensions creates complex forms, the concept of a center might hold an even greater significance, representing a nexus of balance and a point of origin for the object's extension across the various dimensional fabrics. It is here that we can propose a novel interpretation. The choice inherent in the axiom of choice, the seemingly arbitrary selection of elements from infinite sets, might not be a purely abstract mathematical operation, but rather a reflection of a fundamental physical principle operating within the 11-dimensional reality, the intrinsic tendency of geometric objects, including the mathematical constructs that represent physical entities, to be defined and anchored by a central point. When we construct a Vitali set by choosing representatives, we are, in essence, mirroring a physical process of centering or defining a fundamental locus for each equivalence class within the higher dimensional geometric landscape. The non-measurability that arises might then be a consequence of attempting to apply a lower dimensional measure, Lebesgue measure on the real line, to a set whose true nature and structure are rooted in a higher dimensional geometry, where the concept of size is defined differently, perhaps in relation to these fundamental centers. This reinterpretation finds further resonance when we consider the act of measurement in quantum mechanics. The collapse of the wave function, where a particle in a superposition of states seemingly chooses a definite property upon observation, has long been a source of philosophical debate. Within the 11-dimensional model, this choice could be analogous to the centering process we are proposing for the axiom of choice. The observer, interacting with the quantum system across multiple dimensions, might be forcing a manifestation of the particle's higher dimensional state that is centered within the observer's 4-dimensional frame of reference, thus resolving the superposition into a single, definite outcome. Furthermore, the 0 dimension, as the ultimate center of potentiality within the 11-dimensional model, could be seen as the source of all choices in the manifestation of reality. The unfolding of the everyverse from this point of origin might be a continuous process of centering and defining existence across the 11 dimensions, with consciousness, perhaps linked to the 0 dimension, playing an active role in this cosmic selection. The incompleteness observed in mathematical models like those involving Vitali sets might then be a reflection of our incomplete understanding of the underlying physical geometry and principles operating within the 11-dimensional universe. By reinterpreting the axiom of choice not as an arbitrary mathematical tool, but as a manifestation of a fundamental physical principle related to the centering of geometric objects in higher dimensions, we might unlock new avenues for resolving mathematical paradoxes and bridging the gap between the abstract world of mathematics and the concrete reality of physics. The seemingly problematic nature of Vitali sets might not be an inherent flaw in mathematics, but rather a signpost pointing towards a deeper, more geometrically rich understanding of the universe as envisioned by the 11-dimensional model. Please like, subscribe, and share if you enjoy the content. It really helps the channel.